Right, in this video, we're going to discuss the potential energy that is specifically caused by the gravitational force. And like when we studied forces, we're not going to worry about the kind of more general abstract version of gravity that you would need to study astronomy and traveling to the moon and things like that. We're just going to focus on everyday gravity, the way that we experience it here on the surface of the Earth. So remember, the gravitational force, is mg pointed downward. Correspondingly, the potential energy that is stored by gravity is given by a very simple formula. It's m times g times h. So m is the object's mass, g is good old 9.8 meters per square second, the gravitational acceleration, and h is the object's height above h equals 0. And just note that up is the positive direction for this, and that we don't have a choice on, because you have to build the gravitational energy in such a way that the gravitational energy should go up when the object goes up, and the gravitational energy should go down when the object goes down. So that's pretty simple. The gravitational potential energy is a very simple one. The only thing that can be a little bit confusing about it is I mentioned in a previous video this concept of reference points for potential energy. That's going to become very important when it comes to this potential energy. So I mentioned in a previous video that zero potential energy has no universal definite meaning. And likewise, positive and negative potential energy have no universal definite meaning. So in other words, if you tell me the potential energy of this system is negative, in general, that doesn't really help me at all. That doesn't actually tell me anything, because it's totally arbitrary what you call positive and negative and zero for the potential energy. And this gravitational potential energy is a really good example of that. Let me give you a very simple example. Suppose that I lift this object up a little bit. I lift it up to here. And I say, well, calculate the object's gravitational potential energy? And you say, okay, no problem. I'll take the object's mass times g times this height above my hand. And that'll give me the gravitational potential energy. Well, then what if I take my hand away? Now the object is above the table that you can't see out of the frame here, and the height above the table is higher than the height above my hand was. Did the gravitational potential energy change because I moved my hand? No. The only difference is when I had my hand here, you were thinking about h equals 0 as being my hand, but when I move my hand, now you're thinking about h equals 0 as being the table. But guess what? I'm actually not sitting at ground level right now. I'm actually one floor above the ground. So actually the height above ground level is actually pretty high. So it's arbitrary in that sense what you think of as being h equals 0. Okay, so h equals 0 is an arbitrary concept, and u equals 0 occurs where h equals 0. So u equals 0 is also arbitrary. It doesn't have any specific meaning. However, you must clearly choose where h equals 0 is, and stick with this choice for the whole problem. So it's arbitrary where, you know, if you want to measure this object's height above my hand, or whether you want to measure it above the table, or whether you want to measure it above the ground outside the window behind me, is fine. You'll get the right answer no matter how you do it. But you have to know which one you chose, and you have to do the same thing for the initial state and for the final state. And I'll show this in the examples I do for this concept. It's just something to be aware of. Make sure that you know where you are putting h equals 0. And personally, I like to always mark that in my sketches. When I sketch the initial and final state, I mark where h equals 0 is located so that I can't forget, and so that I can reference that when I do make sure it's in the same spot for the initial and the final state. As long as you do that, gravitational potential energy is very easy. That's really the only thing that can go wrong. So I guess I'll end this video here, and all that remains is really to show you some examples of how to use this formula in conjunction with the other energy concepts we're learning.